Today, we're really privileged to have Vijay from AWS. He's a senior architect, is going to talk to us about trusted execution environments and specifically Nitro Enclaves. And then from our side at Kaleido, we have our head of protocol, Jim Zhang. Both of them have really beyond impressive backgrounds in enterprise IT and enterprise blockchain. So really happy to have them along for today's presentation. I'm going to fly through some slides and then we'll turn it over to the stars of the show here. So just a quick intro to Kaleido. At a very high level, sort of three tenets really encapsulate our platform. Built for modern business networks, so entirely industry and use case agnostic. We are the backend, we're the runtime infrastructure, so applicable to finance, supply chain, government, healthcare, you name it. We're not going to dive too much into the platform today, but as folks use it, you'll see that it is very radically simple, both from the interface and both from the API layer. So every single action in the platform, we've given you a simple, clean, RESTful API underpinning that action. And then lastly, very much built for the enterprise. So enterprise in the DNA with major compliance levels for InfoSec, key management, high availability, DR, et cetera. Kaleido, we span both of the major cloud providers. Of course, AWS is who we launched with, and we're on stage announcing a partnership back in 2018, almost a lifetime ago. And then after the fact, we added Microsoft Azure, allowing for true multi-cloud, multi-region, global, hybrid, fully managed blockchain networks. We support the best of breed enterprise blockchain clients, so the various breeds of enterprise Ethereum, core to Besu and Geth, and then we also support core to OS as well. Pretty straight approach when you come to Kaleido, removing the need to become an expert, on crypto primitives, on peer-to-peer messaging, on these new node clients and consensus algorithms. So providing you with the infrastructure to host your smart contracts, perform your mining, also providing you with, clean abstractions of really complicated APIs, and then sort of the run phase as you do need to decentralize and grow your network. Very easy to onboard new members, add new regions, add new clouds, and also stay in line with your enterprise InfoSec compliance requirements. So Kaleido, one portion of the platform is, yes, we are blockchain as a service. We're making it very easy to run your Ethereum or your core to networks and add new members. But you can also sort of think of us as a cloud catalog. We've given you those components, but then we've given you all of the other building blocks that are going to get layered into your solution, whether it's around wallets or key management, whether it's around storage, whether it's around integration with your core back office processes. We've added all of these as plug and play services, and again, with a very simple API underneath it. So we think of Kaleido really as a consortia as a service, this digital transformation platform built for modern, complex, multi-party networks. And you can see that we provide these really rich admin dashboards where you can have as high-level macro of an insight as you want, and then drill deeply down into sort of granular topics and metrics, whether it's smart contracts or whether it's actual health and monitoring of the runtimes of your containers. One unique sort of tranche in Kaleido is we've separated the platform into three distinct tiers. So you have your control plane. This is where we make it very easy to do sort of the consortia or the network onboarding, smart contract management, sort of the shared line of sight into your business network. And then we have our data plane, right? This is our smart contracts. These are our nodes. This is the consensus algorithm. But we've also layered, really, really important pipes, I guess, so to speak, inside of this layer, allowing for B2B collaboration processes, securely exchanging, lightweight messages or, arbitrary data payloads, images, legal contracts, videos, etc. And then you have your member plane where you can be in full unilateral control of your runtimes, of your processes, and any core integrations you have into, for example, your AWS cloud estate, whether it's key management, whether it's storage, whether it's log streams as well. So it's a very distinct, very clean separation of these three different tranches inside of Kaleido. What we've noticed, sort of a blessing in disguise of COVID, is COVID sort of sped up this realization of how broken some processes are. And just a few examples, we can see this in supply chain, we can see this in healthcare, government processes, Basically, we have all of these siloed processes where data is not able to be efficiently and securely changed. So the idea here, what Kaleido is making it very easy to do, is cleanly integrate all of these siloed back office processes, but also comply with the levels of security and privacy that are going to be required to share a portion of this data. Something that's become abundantly clear to us as we've gone through our enterprise journey for close to 6 years now at a previous company and now at Kaleido, is that the blockchain, while incredibly important, is a really, really small piece of the overall stack, of the overall solution. So if we think back to that cloud catalog slide where I was talking about key management, about storage, about integrations, this is where you need to have access to all those components that'll really build out the stack. And this is, at a high level, how we look at sort of, just a vanilla 101 enterprise architecture stack here. And all of these layers, whether it's, integrating off-chain data, securely exchanging data, performing on-chain private transactions, consuming events, B2B messaging processes and ESB integrations, on and on and on. Kaleido has provided either a first-class citizen inside of the platform, for example, our abstraction of the Ethereum API, or we've provided a plug-and-play service that can accommodate these requirements in the middleware, in the transaction, or in the application tier as well. So finishing up with the slides, our goal for you is to not worry about, the core technology, crypto primitives, standing up containers, standing up nodes, and performing consensus, but to identify, the current problem in your business process, focus on the business logic, focus on the application tier, and quickly get into a pilot phase, and then have the confidence on the platform to actually scale this to dozens or potentially hundreds of members across multiple clouds, or even in your own on-premise data center, really flattening the curve here from POC to pilot into production. Touched on enterprise grade, and it really is in the DNA. So just a handful of bullet points here that you get out of the box with Kaleido, ISO 27000 certification and SOC 2 certification, a really awesome, breadth of variety in terms of key management, including being able to manage your keys in an AWS Cloud HSM cluster, enterprise identity constructs with X509 certificates, HADR, and even the ability to run your nodes, self-managed in your own private data center or your own private cloud. We've talked about a lot of these in the past, so I'm not going to go ad nauseum into them. And then just finally wrapping up here, Kaleido really in-house, we do have the expertise, whether it's just in core IT systems or whether it's in blockchain or some of these bleeding edge technologies associated with blockchain like TEEs and like zero knowledge proof. So we have two subject matter experts on the call today, in Jim and in VJ, that can talk about these. So I'll wrap up the slides with that right there. Quick snapshot of a handful of the enterprise customers that have been in production for many years on Kaleido. So just a testament to the fact that we are truly use case and industry agnostic here. A couple final pieces of admin before I check it to Jim. We have recorded all of these sessions. So we've been doing these for close to 8 months now, and we've touched on all of the pieces inside of Kaleido. We've looked at full stack applications. We've looked at specific use cases. So if there's anything that is interesting to you, Truffle, Chainlink, Cloud HSMs, for example, these are all curated and available on our YouTube page. And then the last thing I'll mention is that it is free right now to sign up for Kaleido. It's always been free. You can have access to our starter plan, and in a matter of 30 or 45 seconds, actually have your own private enterprise blockchain environment running enterprise Ethereum or running Core to OS as well. So the final thing before I stop sharing, if there are any questions, any comments, please don't hesitate to use the Q&A or use the chat. Jim, VJ, and myself will be monitoring that throughout the call. So that's my portion, and I'll turn it over to Jim, and then we'll get to the star, VJ.
Hey, Nick, if you can reshare, so and I'll just use your slides. It's only a couple.
Sure.
Awesome, thanks. Thanks, Nick. Hi, everyone, this is Jim. So for this portion, I'm gonna just use a few slides to set the stage for VJ to talk about the role of the trusted execution environments in the bigger context of privacy for enterprise networks. Next slide. So Kaleido, the leadership of Kaleido has been in the space, in the enterprise blockchain space for half a decade now, and the Kaleido itself as a product has been available for more than 3 years. So that's like a really long time in this really fast moving space. And over the years, both from observing the requirements from our customers, but also keeping a close eye to the progression of the technologies, both by the ecosystem of developers, but also by academia. Privacy has many different flavors. We summarized in these these 5 categories. Private transactions is a way to make transactions involving only the parties that are direct counterparties to the transactions. So other parties, even if you are part of the same blockchain network, if you're not direct counterparties to the transaction, you wouldn't know what's going on. But you will still be responsible for keeping that transaction, the fact that transaction happened, keeping that fact safe and immutable. So that was the first bubble on the very top. Kaleido supports Quorum, Hyperledger Besu, and Corda. They all have private transaction support. In fact, for Corda, all transactions are private. They only involve the parties that are actually part of the transaction. And all the transactions are either hashed or in other means pinged by other parties, so that the fact that the transaction happened cannot be changed after the transaction has been exchanged among the direct parties. So the second approach to privacy is using blockchain to orchestrate off-chain data exchange. So this would be maybe a secure message that needs to be encrypted end-to-end and then exchanged among parties, or maybe it's a document of unstructured data that needs to be exchanged. But using blockchain to orchestrate the broadcasting and circulation of the message among the parties on the off-chain layer. So blockchain in this case is responsible for using events to notify the arrival of the messages and the exchange of the acknowledgements. So Kaleido has good support for all of these approaches, and we'll touch on the third one, which is trusted execution environment that uses very different approach. And then finally, the fourth and the fifth are zero knowledge proof and multi-party compute. So Nick, if you go back like 3 slides. I know I'd be all over the place. Keep going back.
Just tell me when to stop. Apologies.
Yeah, to private transaction. One more.
Okay.
There we go. So Quorum, Besu, and Corda all take very similar approach where a subset of the blockchain participants are designated as the parties that are purview to the content of the transaction. The rest of them don't know the input and output of the transaction, but they do have the responsibility of either through a hash or through signing off on a subset of the transaction information to keep the transaction secure. So the transaction will be trusted to have happened, and no one can change the content of the transaction after it's been saved in the ledger. Next one. In terms of blockchain orchestrated off-chain exchange of structured or unstructured data, Kaleido supports app-to-app messaging. This is structured JSON data that can be encrypted end-to-end and exchanged between 2 parties A and B through a reliable backbone on Kaleido that's backed by Kafka. And both sides will be able to look up the other side to make sure it is indeed the party that they claim to be by using a blockchain-based on-chain registry in terms of their identity and their public key. Next one. Kaleido's document store is similar to ActiveWeb except that this is document exchange. So it's unstructured data and saved in the form of files. While you are exchanging files, they can be saved in either a native Kaleido storage, or you can designate Kaleido to send those to your own AWS S3 buckets or Microsoft Azure Blob Store. Again, these are end-to-end encrypted, and they are using the on-chain registry to ascertain the identity of your counterparty that you're sending, exchanging the documents and sending messages with. So they're highly secure. So the last one we have supported on the platform by default is zero-knowledge-based token transfers. So obviously, zero-knowledge proofs are general-purpose technologies that can be used in many different scenarios. We realized token is a really, really powerful programming model. So we added zero-knowledge proof to a token scenario. So if your solution involves a ERC20 token, you can use this technology to secure your token transfers so that everybody is able to send tokens to everybody on the network, and everybody gets a copy of the zero-knowledge proof, but unless you have the right keys because you're part of the transaction counterparty, you won't be able to actually know what's going on. But you will still be able to verify that the proof represents a honest transaction. So that's the idea behind zero-knowledge proof, and Kaleido has it out of the box with a really easy to use service to work with. So next one, we're getting to trusted off-chain compute. So this is a technique where the transaction inputs are hidden, but the logic to process the transaction is public, so that all the parties in the network can help validate that when a proof in the form of attestation is presented, everybody can help verify that the correct code has been used to process the transaction. So the idea is, I may not know what you did, but I do know through my own verification of your proof that you have done it honestly and correctly, according to my understanding of how the logic should be. So that's the idea behind off-chain compute, and trusted execution environment is one form of off-chain compute. So next one. Now, getting finally down to today's topic, TEE. It's utilizing hardware to isolate the processing and the data that are designated to be highly sensitive, so that even if somehow the hacker got access to the physical machine, to the physical operating system where this process is running on, they would still not be able to access the code or access the data that's involved in this transaction. So it's a highly secure location. It's usually designated as with the term enclave. Is a place for highly sensitive data to be processed, and it's great for a cloud-based environment where you are trusting a third party to host your compute node. You can be guaranteed that the cloud providers, because they have access to the physical machine, to the operating system, even to the hypervisor level, they would still be shut out the access of the actual code and the data involved in the transaction. So with all that as the background, let me turn over to VJ to talk about AWS Nitro Enclaves, which along with Intel SGX are some of the leading technologies behind TD. BJ, over to you.
Thanks, Jim. Yeah, I'm just sharing my screen. Guys can see it?
Yep.
Looks good.
Okay. Bit of introduction. So I'm one of the senior partner solutions architect with AWS blockchain segment, helping the ISVs globally to fulfill the blockchain dreams. Have over 25 years of experience in the industry, 5 months with AWS right now, and doing blockchain for more than 4 years now on DLT. Implemented roughly 24 networks, all sorts, POC, MVP, pilot, production, 100 plus use cases, some of them very interesting and very unique. So in this session, I'll be covering about enclaves and more specifically AWS Nitro Enclaves and what customers are looking for and what are some of the basic properties of enclaves. So what is cryptographic attestation and some of the key features of Nitro Enclaves, and a theoretical walkthrough of how you can use an encrypted S3 data and AWS KMS key store along with enclave to process that some information without the host being exposed to any kind of data in a plain text format. So this is the agenda. Hopefully we'll have some time for QA. I'll just start jumping into the content. So today, so most of our customers and you are handling high sensitivity data on EC2. Some of the examples we could go after are very commonly used by information, financial records, intellectual property, trade secrets. The AI and ML world is really taking shape and taking over the normal automation, the proprietary algorithms, and the government secure social security numbers, passports, etc., etc., etc. So these are some of the commonly used highly sensitive data, and that we see from our customers who process them in EC2. So what is the basic ask from our customers is to reduce the surface area attack during processing the sensitive data. So how do we do that is by creating some isolated environments inside EC2 to process this sensitive data, and also providing access to limited access to their own system administrators, developers, and also other applications running within the same environment or different environment. In a typical EC2 instance, you'll have different kind of users accessing the EC2 instance. There could be some third-party libraries for supporting OS or supporting some other applications. That could be multiple applications running, for example, a web tier or a middle tier application, and that is the supported OS for the EC2. And what we commonly call an enclave is an isolated environment where an encrypted data can be processed securely using some kind of a technique, so that none of these guys on the other side or some kind of intruder is exposed to this plain text data. So let's see what we were doing previously. Let's take Amazon as an example. E-commerce platform during early 2000s, when Amazon was small at the time. So we did had some rigid architecture, but again efficient. If you see here, the orange blocks represent the Amazon's. For example, the Amazon's e-commerce platform, where we have different tiers: web application tier, backend tier, middle tier services, or services that talk to backend, and also the core databases, to store some order information or customer information, or where is your orders, things like that, etc. So usually how we used to do payments or payment processing is generate a token, and the token service will kind of authenticate and authorize the payments, and we will just pass the token to the payment systems, and the payment system will just make the payments possible for the customers. So we never used to store customer information like credit cards and other sensitive information inside Amazon. So this has changed over time. And again, what is the problem with this kind of setup is, first thing is it's kind of bulky. So we need to start creating these kind of environments. Talking about scale, it does impact a lot from scalability perspective. And these are going to be, highly remote systems, and somebody needs to apply a patch or administer something. They need to, get into these systems and then start applying patches or code fixes and things like that. So this is probably the early 2000 architecture. Even some of us are very familiar to it. So moving on with what the limitations of this architecture is. We can create only certain limited functionality and limited in size in terms of capacity and processing power. And the surface area is limited because nobody knows where these payment processing systems are, and no internet access. That's a good thing, and no interactive access. And nobody can even access into these from the outside world. It kind of solves the problem in those days, but as the business grows, these architecture become very rigid and needs to more innovation. And that's when the EC2 came into picture with their unique virtual private cloud options. So as some of you are very familiar, the architecture gets translated into a VPC model where all the public components can be exposed using a public VPC, and the private components can be hidden behind the private VPC. Again, here, there are certain limitations that we have when we are processing sensitive information or private information. Again, that could be a trade-off between performance, that could be a trade-off between software maintenance, that could be a trade-off between whether you want to move on to the newer architectures, because the world is evolving with so many unique architecture patterns and design patterns that we want to catch up with, and also the business is growing for everyone. So let's see, what are Nitro Enclaves, and how does Nitro Enclave support some of these business critical problems and the surface area attacks. So we all know the EC2 instance as a whole, and we have a portfolio of EC2 instance that you can create with AWS. So the Nitro Enclaves here as shown are highly isolated, meaning that right now the Nitro Enclaves doesn't support any storage. That means it's not a persistent based option. It's only in-memory processing capacity, compute capacity. So it absolutely has no network access. That means it doesn't have an IP address because the DNS and NTP is also disabled. It doesn't have any interactive access like SSL. But what happens here if there is a intruder or some kind of a compromise that happens with this particular EC2 instance? The instance is compromised, but whatever you have in this enclaves are still intact, and the intruder cannot go and access something in the enclaves. So this again is the very basic information on why we have to go into something like a enclave, and how Nitro Enclaves will help us do trusted execution environments and process sensitive information without exposing the plain text for various subject matters involved in a particular transaction. So let's move on to the actual content. So here we have to understand two different terminologies first. One is Nitro, the other one is Enclave. So I'll try to touch base, what is Nitro and why it is the go-for system with AWS when it comes into enclaves, and also some of the benefits that Nitro brings into the compute capacity and virtualization and all that. So Nitro Enclaves provides the secure and trusted environments for sensitive data processing, like I mentioned before. So it built on productions within the Nitro EC2 systems, and it provides a convenient and familiar model for accessibility and productivity, the developers teams, meaning that you don't have to do extra coding or anything extra. So as long as you launch an EC2 instance, it's just another line of command that you need to enable to invoke a enclave inside the EC2. So it's completely open sourced. You can actually go and look at the Nitro EC2 enclave code and how it is architected, and build something that you want to extend, and you have some of the ideas. You can play with that. All the heavy lifting as usual, including the cryptographic attestation are taken care by AWS using the other native services within AWS, like Amazon Key Management System service, and also the Amazon Certificate Manager. So this actually removes a lot of piping and plumbing work that we usually do from a developer perspective. So the first thing that comes to mind is, okay, what is it going to cost me? So there is no additional charge for AWS Nitro Enclaves. So whatever the computation and storage capacity that you provision for the regular EC2 instance, that's what you pay for. Again, keep in mind about anything that AWS charges is not for data that is coming in, only for the data that gets stored, and then that data that goes out of the AWS cloud. So little bit on the Nitro system. So Nitro system was launched a couple of years back. In fact, the Enclave was launched only 40 days back. It's pretty new service from a maturity perspective. Some of the key components in a Nitro system that we need to be aware of is the Nitro card, the security chip, and Nitro hypervisor. So there is a AWS subsidy called Annapurna. This subsidy actually creates all these Nitro cards and chips and the hypervisor protocols for us to actually power the Nitro system. And actually, this is where the advantages of the Nitro comes into picture. So let's talk about what happens to the EC2 instance without AWS Nitro, or any kind of virtualization that happens without AWS Nitro. So if you take this blocks of components here, pretty much you can see there is one machine that takes up 70% for the customer instances, and there's a heavy layer of hypervisor, any kind of hypervisor that you want to use for virtualization, and anything that you want top, including network layer, storage, and other monitoring metrics services for management. It does takes the resources and shared between all these components for the networking, storage, and management layer. So this actually, not a right model for areas where we look for dedicated services and not sharing the resources with CPU, core CPU, and any kind of virtualization, bottlenecks to be, overcome. So let's see what some of the drawbacks of the virtualization without Nitro. Like I mentioned, it runs on the virtualization functionality runs on the same CPU as the customer instance. Like I mentioned, it takes away a lot of resources, and hardware, on-system hardware and software security rely on the operational state, and that means if anything is compromised on the hardware, then everything is exposed. So let's quickly see, what is the difference between Nitro systems. So Nitro systems comes with two distinct hardwares, which you cannot see physically. But in my previous slide, I did point out the Nitro card and Nitro chips. So those are inbuilt in the hardware, and the isolation is at the hardware level, and you get a complete layer for your networking, storage, and monitoring, security, and management of your services on top. So this adds another level of sophistication, because it's completely compartmentalized, and it has its own hardware security and software security, and you can do a certain level of virtualization on top if you need to. So let's jump into Nitro Enclaves. So the ability to create isolated environments with the existing parent EC2 instance and how it can be done. So we all know what is an EC2 instance. Again, there's a variety of instance types and permutation combinations you can pick up to create an EC2 instance. And the Nitro hypervisor is going to be the the underlying virtualization software for the EC2. So you can start adding enclaves, which will act as a separate virtual machine internally, but you won't see them, when you use them. So even though this particular diagram depicts, EC2 can have multiple enclaves in it. So right now, the facility to launch an enclave is only 1:1. That means if you have an EC2 instance at this time, and you can launch only one enclave, but that will change, with the roadmap. I don't have the dates for that, but we can expect having multiple enclaves in EC2 to come pretty soon. So let's look at some of the basic properties of these Nitro enclaves. So it's not a container. A lot of people think it's a container. So there's no persistent storage, and there is no administrator or an operator access. There's no SSH. Basically, it's cut down from all the access via NAT gateway or IGW or TCP, anything like that. So communication to the enclave is only through something called a secure local channel. I'll touch base on this. It's a virtual socket. So it also has a lightweight Linux OS, depending on what base OS you provision, it just add to that. It has an independent kernel, like I mentioned, that's the distinguish between the Nitro and the other agenda systems that you have. And it produces its own encryption keys. As soon as you launch your enclaves, it does have its own encryption keys. We'll see that shortly. So, so like I mentioned, if you have a parent instance, which is your EC2, and you create a enclave here, you can see the app A want to communicate with the app B, and that is possible only through a VSOC, which is a virtual socket. I think this is an open source virtualization software. So it's 32-bit context identifier. So which helps, and there are some kind of helper agents running in the EC2 instance, again, which is not accessible by anybody who has access to this EC2 instance, which can actually help translate some of the data in and out. We'll see an example shortly how it does. So how it works really. So first is, you have an application that you want to put into an enclave, especially, let's take an example that you have a complex algorithm that you want to put it in an enclave and then treat that as a secure and sensitive processing algorithm. So you take the application, you provision and regular EC2 instance, choose a type and a capacity. So here, the example I've given is M5 for extra large, and which has a 8-core 64 GB memory. So using this application, with the Nitro CLI or Nitro CLI, you create an enclave image. It's called EIF file. And again, using the Nitro CLI, you can actually specify, how much of the core capacity, compute capacity they want to give it to the Nitro enclave. In this example, since there are 8 cores, it's kind of given 4 cores and 44 GB for the enclaves. So it's just very simple from an execution perspective, just 4 lines of command. The only difference here is you need to create the application as an enclave image file here, and that enclave image file gets deployed into an enclave. So next is what is the support for cryptographic attestation? So so enclaves can produce attestation documents, and with respect to the Nitro, it is signed by the Nitro hypervisor. And that's why if you see the Nitro hypervisor is very important from understanding, the Nitro enclaves. So the signed attestation document contains, a lot of information. I have just listed a few information here. So it has the public key. The private key never leaves the enclave, and has of the enclave image and something called platform configuration registries, usually referred as a PCR. You can actually see the PCRs as you create the enclave, and these PCRs will be useful to actually create a policy file with KMS, and that's how you restrict access to who can actually process information from these enclaves. And also, you can add a nouns. So this combination will create a cool attestation document, which will be issued by the Nitro hypervisor. So that actually signifies that this enclave or this attestation document can work only with each other, and no other signature or no other attestation document can be replaced for access. So a quick example of how the integration with AWS KMS here. So the once you have the enclave created on the attestation document, so it does spits out the PCR. You can actually use a command line tool to find out the PCRs for the particular enclave on the attestation document, and then you can create a policy in your key management service to make sure the access to this particular enclave via using the attestation document is valid. And the reason why we should do that is, for some reason the attestation document or the enclave image is replaced with a newer image, it just protects that the attestation document needs to be reissued because the PCR values will be changed. So this is one way of ensuring that only the particular image and the checksum that's used for creating the attestation can be used for execution as well. Some of the key features include flexible resource allocation. You can actually go rapid in terms of how much resource that you want to allocate to the enclave. Just be sure that you have the base EC2 instance supporting at least 2 vCPUs. That's the minimum that is required. And like I mentioned before, the cryptographic attestation is also a key ingredient. Integration with the key management service, and there are like pre-packaged packaged enclaves, again open source from AWS, available for your exploration. Some kind of samples that you want to explore, or you want to use the samples and write your own enclave images. That is possible as well. Some of the basic CPU-based instances that can be used for Nitro enclaves, M5, R5, C5, Z1D, the newest one, and there are like many more. The Graviton instance is not supported right now, but that will be available, as part of the roadmap, and you'll hear it from the AWS announcements. So it's really up to us how we can actually configure the CPU on the memory. So based on the workload of the application that you put into the enclave, you can actually allocate it. Once allocated, it just consumes that particular bucket of CPU and memory for the Nitro enclaves. So I think we spoke enough about the cryptographic attestation. Just want to jump into the example here. So here, with the example, I've taken 3 players. The data owner who has the highly sensitive data, the sysadmin and the developer. The sysadmin could be who manages the lifecycle of the EC2, and the developer is who processes the code for processing the highly sensitive data. This could be 3 different tenants, or 3 different companies working together. So here the process is pretty simple. With respect to setting up the encryption with the S3, you follow your standard procedure of creating a new symmetric customer master keys and generate the data key from the CMK. And the highly sensitive data on the data key forms the encrypted data, and upload this encrypted data on the encrypted key to the S3 bucket, just like how you do for normal encryption with KMS and S3. So next step is using an application to create an enclave image. Inspect the code from the developer perspective. For example, the developer has the code for processing the sensitive information. So make sure it's written, and you can use the Nitro CLI to convert it into an enclave image. So here, it's recommended to do a Docker, but it need not be a Docker, to actually run an enclave. So note on the measurements here. Measurements means the PCR 0, 1, 2, 3, which is very important. And using this PCR 0, 1, 2, 3, you add the condition to the KMS key policy management file, so that this image is accessed only when they provision the when they provide the KMS key policy, and the particular user has that particular policy assigned. So how do you process this information? So first is you from the parent instance or in an application where the system admin want to process some reports, for example, on this sensitive data. From the S3 bucket, using the encrypted data and the encrypted data key, download the data to the parent instance. And using the VSOC information and the helper agent part of the parent instance, provide the encrypted data and the encrypted key via the VSOC into the enclave application. And here the decryption needs to happen, and the processing of the information needs to happen with respect to the information that we pass into the enclave. But before that, a proper attestation need to be provided. So in this case, the enclave will pass on the signed attestation from the hypervisor, which is already providing you the attestation document. So this needs to get verified by the KMS service again. So the encrypted key, which is still protected, and the attestation document gets passed back using the helper agent, and then it gets verified by the AWS key management service. So key management service here provides two functionality here. One is the attestation document signed by the Nitro hypervisor, and the PCR on the KMS key policies matches the one in the attestation document. So that's what verified there. And once that is there, then the data key will be passed back, which is a public key now, which can be used for decrypting the encrypted information and processed by the application for understanding the plain text. So this completes the simple process of how a simple workflow for processing sensitive information using traditional AWS services along with the enclaves. Some examples that we can talk about processing sensitive data here is again using some kind of a medical reports or some kind of private information that you want to get for a particular state. For example, it's a COVID situation, and how many co-workers in a particular government agency is infected by COVID, and the government agency want to find only a number and not the people. Imagine the enclave kind of has the algorithm to pull in the number based on some kind of standard inputs. Again, you can use DynamoDB or any traditional AWS services to pass in the data into the enclave with the encryption key and the attestation required, and the processing logic with the enclave or the algorithm within the enclave will throw back the number. So this is one of the very simple use case that we can think about sensitive data processing. So with respect to multi-party collaboration as an example, let's go back into the Bob and Alice popular example. It's more on like a ZKP, zero knowledge proof validation, where Alice and Bob has a set of data or a list of data which they want to verify across each other and find out what are the common entries they have. For example, who has been uh, in their customer list for some time, and some kind of a verification they want to do with certain data sets in a kind of a list format. So in this case, Alice creates the attestation based on the sensitive data. Again, Bob creates similar, and the enclave image with the processing logic can be done by a third party here, or any one of them, like Alice and Bob, can host that enclave. And the similar processing what we saw for KMS and the enclave processing example applies here. So here, Bob and Alice will pass on the data along with the attestation information and the key information. So the enclave will kind of compare the data list and provide them, what is the difference in the data list. Again, very effective use case in a multi-party collaboration. So going on, some more examples within property or intellectual property rights, or a PR kind of application. Um, the commonly used example, in this area is the machine learning models. There could be millions and millions of hours running a model and finding out something from these models. There's a way you can encrypt the material and then baked into an enclave image. So these images can be retrieved by the image when the image gets boots up. So when the stub that's is booted up, and the enclave image that will verify that and decrypt and execute the encrypt application, and it will identify which machine learning model that should use, and the model will learn from that. So one of the very significant use cases that we see in the machine learning areas. So for people who are new to enclaves and AWS Nitro Enclaves, so I provided some reference here, how to get started with Nitro Enclaves. So I also link for the GitHub repository. So there are various deep dive sessions happening with the current reinvent on the AWS Nitro Enclaves, and also a reference to the AWS Nitro System, which is the core behind processing this enclaves and creating these enclaves and getting the plain text information in a secured way. So I'll stop here for Q&A. I don't know whether we ran over.
Hey, Vijay. Looks like there are some questions for you from the audience in the chat. I think the first one was, how do Nitro enclaves differ from other secure compute options? If I'm using EC2, what is the benefit of using enclaves versus non-AWS trusted compute environments?
So I think this is purely based on Nitro architecture. So that's the basic difference. And also all the plumbing that you need to do if you bring in a third party or a custom built enclave is eliminated. And that's where the Nitro power comes into picture. So I've given some reference links in the deck, through which you can actually understand what is the difference between Nitro enclaves, Nitro System, and the other market providers. But again, this is only a recent launch, so we can look for more features getting added into these enclaves with more capacity.
Thanks, Vijay. So that was from Fletcher. Hopefully that was, there was some, if there are follow-ups from Fletcher, feel free to post here or just go ahead and speak up. Another question from Mike was, do you have a detailed list of all the memory capacities and costs associated with transactions somewhere?
So like I mentioned, there is no cost for the enclaves. If it's going to be easy to cost, then definitely that can be taken from the AWS side. There is a AWS calculator that you can use for pricing EC2, based on the capacity, compute, and storage that you pick and the instant time you pick, you will get to know the cost. I can pass on the link post the presentation, or somebody can actually Google and find. If you Google AWS calculator, you'll find this information.
Awesome. Thanks, Vijay. So the next question is somewhat related to both Nitro and Kaleido, also from Mike. If we have keys managed via Kaleido in HashiCorp Vault, to use Nitro in particular, do we need to switch that service to AWS Key Management Service? And I attempted to answer. Vijay, let me know if that makes sense or not.
Mm-hmm.
I thought the question was they were using HashiCorp to sign transactions to send to some system, maybe to the blockchain. But now if they want that some processing to be done through Nitro, since Nitro requires a KMS-based key, signing through that attestation-based decryption, do they have to ditch their existing keys and then switch to KMS? I thought those are on two different layers of the architecture, where KMS is required when the host VM, the parent VM, talks to the enclave through the local channel. Because you can't interact with Nitro directly, you have to go through the parent VM. So when you talk to the parent VM, you can still use your external signing keys, whatever you were using before. But when you set up the communication between parent VM and the enclave, that's where KMS is involved. Is that understanding?
Yeah, that's right. Because Nitro enclaves are completely different from the ask, right? Here the question is more about how do we use key management. I think your answer kind of fits the best.
Cool, great. I think the last question also from Mike was, do you have a pricing comparison between Nitro, Intel SGX, and AMD Secure Enclave, SEV, I don't know what V stands for, along with implementation costs?
Like I mentioned, I can provide the Nitro capacity, as it is part of the AWS offering, it's very easy to find out. I don't have a chart right now, but and I can provide you the link for you to find out the Nitro capacity.
Awesome. Cool. Last question so far from Mike. Does that key management service become free via AWS and Kaleido, or is it extra? So I guess they have to provision keys in KMS, and they have to still pay for it even if they're using it with Nitro. Is that correct?
Yeah, that's right. So I think it's a fair question. Anything that you provision on AWS, I still recommend start using the AWS calculator and play with the numbers. That kind of will probably tell you more accurate. I don't want to again promise, but any service that you have, just use the AWS calculator, and then you can find out what exactly the numbers are going to be, because again, depends on the basic underlying services that you provide and how many keys, key rotation policies, and things like that.
Awesome. So I think that's all of the questions so far. Looks like Mike was pretty satisfied with your answers. Thanks very much, Vijay. Guess back to you, Nick.
Yeah.
Wrap up.
Yeah, that's super. Thanks so much, Jim and Vijay. Really interesting material there. I've just pasted 3 email addresses in the chat as well for folks if they have any technical or commercial follow-ups. Feel free to use any of those endpoints, and you'll either get to myself or you'll get to the broader team. As I mentioned at the beginning, this was recorded. We'll be sending out the recording, and you can also grab it yourself just on the Kaleido YouTube page. Free to sign up for a Kaleido account. BJ's shared a ton of information about AWS features and pricing estimations. So I encourage you to check out the pricing calculator there. And then please stay tuned. We'll have some more partner Tech Tuesdays coming up as we reach the end of 2020 and into 2021. So we'll send out marketing material and associated information related to those. So one final thanks to both the presenters today, Jim and BJ. And we wish everyone a happy rest of their Tuesday, and we hope you're staying safe and healthy. So thanks again, and we will see you soon on an upcoming Tech Tuesday.